It's an exciting time for space exploration. We've got companies, countries, and even private individuals all racing to make their mark beyond Earth. Can you imagine? Not just government programs anymore, it's the private sector too, driving innovation and making space more accessible. This is a whole new era. NASA is still leading the way, of course. The Artemis program is about to take us back to the moon. That's right, after more than half a century, we're preparing to land humans on the lunar surface again. But this time, it's not just about planting flags. This time, it's about staying. Building a sustainable base, a long-term presence, and using the moon as a launching pad for even bigger missions, like going to Mars. And speaking of Mars, yeah, we're talking about it. SpaceX has been making headlines with its Starship, and in 2025 it's not a dream anymore. It's a reality in the making. Elon Musk's vision of humans becoming a multiplanetary species might just come true sooner than we think. SpaceX has a goal: land the first humans on Mars by the early 2030s. That's right, Mars. Just think about that for a second. We're talking about a planet over 33 million miles away, and soon enough we'll have boots on the ground there. It's mind-blowing, but it's not science fiction anymore. But it's not just SpaceX doing all the heavy lifting. China has been making big strides too. Their space agency, CNSA, has ambitious plans for a lunar base and of course their Mars rover missions. If you've been following, you know they landed their rover on Mars, Tianwen-1, and it's been sending back some incredible data. China is making it clear, they're in the race to dominate space. And let's not forget the role of private space companies. Blue Origin, for example, is pushing the envelope with reusable rockets and even plans for lunar landings of their own. Jeff Bezos's company has been designing rockets that are ready to take not just cargo but humans too. And this isn't limited to billionaires, by the way. There's a global network of companies now from Europe to Asia, all contributing to this new space race. Commercial space stations? That's happening. Space tourism? It's already begun. But of course, with all this innovation comes the challenge of regulation. We've got countries pushing for space treaties that will keep things peaceful and cooperative. And there's a lot of discussions on the legal side about who owns what in space. The rules are still being written, and we're figuring out how to make this new frontier work for everyone, without stepping on toes. Looking at 2025, we're also seeing more international collaboration. The International Space Station has been a huge symbol of cooperation for decades. But in the future it might not just be between a few countries anymore. More private players are jumping into the mix, and that opens up new possibilities for partnerships we couldn't have imagined even just a few years ago. And don't forget about all the satellites buzzing around our planet. We're entering an age where space-based internet could soon be the norm for everyone, no matter where you live. Companies like SpaceX with their Starlink project are launching thousands of satellites into orbit, aiming to provide high-speed internet to every corner of the globe. Imagine living in a remote village in Africa or in the middle of the ocean, and still being able to have fast, reliable internet. This is the future that's unfolding right now. But it's not all sunshine and rainbows. With more space traffic comes the risk of collisions and space junk. It's something we're already dealing with. Experts are racing to come up with solutions to prevent this mess from growing out of control. We might be reaching for the stars, but we're also learning that we need to clean up our act up there. After all, the future of space exploration depends on keeping space safe and sustainable. So what does all this mean? Well, it means that space exploration in 2025 is not just about reaching new frontiers. It's about building a future that's sustainable, cooperative, and accessible to a lot more people. We're at the edge of something big, and we're just getting started. This is the start of humanity's bold leap into the stars. It's not just about exploration anymore, it's about living, working, and thriving beyond Earth. And believe me, it's going to be one heck of a ride. Now let's talk about the moon. For centuries we've looked up at our lunar neighbor, and while it's always seemed distant, it's now our stepping stone to the stars. It's not just the destination of the Apollo missions anymore. We're coming back, but this time, we're staying. The moon is going to play a huge role in humanity's journey beyond Earth, and the next couple of decades are all about laying the groundwork. NASA's Artemis program is leading the charge, and it's all about getting boots on the moon once again. But here's the twist. This time, the goal isn't just a quick visit, it's about building a sustainable presence. We're talking about setting up lunar bases, digging into the moon's resources, and using it as a launch pad for missions further into space. This isn't just another flag planting exercise, we're talking long-term habitation. So, what does this look like in practical terms? First off, we need to create the infrastructure to support life on the moon. That means habitats that can withstand extreme temperatures, radiation, and the moon's lack of atmosphere. NASA's been working on concepts like the Gateway space station, which will orbit the moon, providing a hub for astronauts before they land on the surface. But it's not just NASA, private companies are jumping in too. SpaceX is already developing their Starship to transport astronauts to the moon. Blue Origin is working on their own lunar landers. The future is definitely not just government-driven anymore. The race is on, and private companies are playing a big part in turning this dream into reality. The idea of a permanent presence on the moon also means we're going to need resources, on-site resources. We're not just shipping everything from Earth. That's where lunar mining comes into play. The moon is rich in resources like water ice and helium-3, which could be crucial for future energy production. Water is key because we can use it for drinking, oxygen, and even to make rocket fuel. Mining the moon might sound like science fiction, but it's happening now. Companies and agencies are already exploring the best ways to extract these resources in the future. Now why the moon? Why not focus on Mars or somewhere farther out? Well, the moon is close, it's only about 3 days away from Earth. That makes it the perfect testing ground. If we can figure out how to live and work on the moon, we're a step closer to doing the same on Mars. It's the ultimate proving ground for human space exploration. The moon can teach us how to handle radiation, how to grow food in space, and how to survive in an environment that's just so different from Earth. Plus, the logistics of getting supplies from Earth to the moon are much easier than to Mars. So, we use the moon to refine all the tech we'll need for deeper exploration. But here's the thing. The moon isn't all that simple. It's got its challenges. The lack of atmosphere means there's no protection from cosmic radiation or solar radiation, which is a big deal. We're going to need some serious shielding for habitats and equipment. NASA's already researching ways to use lunar soil to create this kind of shielding, which could be a game changer. It's also super cold at night, like minus 280 degrees Fahrenheit cold. So, keeping habitats warm without a traditional power grid is a challenge in itself. And let's not forget about the moon's gravity, which is only about 1/6 of Earth's. That means living and working on the moon will affect our bodies in ways we haven't experienced. Astronauts will need to adapt to the low gravity, and they'll have to deal with potential muscle loss and bone density issues. These are real physical challenges that we're going to need to solve if we're going to make the moon a place where humans can live for extended periods. The moon is also a place where we can learn more about our solar system and our history. It's thought that the moon may have records of the early solar system hidden in its surface. The lunar soil is untouched by weathering processes like those on Earth, so it could hold clues to the formation of our solar system billions of years ago. That means lunar exploration could also answer some of the biggest questions we have about our own planet's history. And there's one more thing that makes the moon so compelling: its potential to fuel future space exploration. Once we set up bases on the moon, we'll be able to launch missions to Mars and beyond with much less cost and risk. We can mine the moon for the resources we need to power spacecraft, which would make interplanetary travel way more feasible. Think about it. Instead of launching massive rockets from Earth every time, we could build and refuel ships on the moon. It could become the gateway to the rest of the solar system. So yeah, the moon is a big deal. It's not just a place to visit, it's a place to stay, to build, to learn. We've got big plans, and the next few decades are going to be crucial in turning those plans into reality. The moon isn't just our neighbor anymore, it's our stepping stone into the great beyond. Alright, now let's take a giant leap from the moon to Mars, the red planet, the place that's been the subject of countless sci-fi movies, books, and dreams for generations. But now, we're talking about turning those dreams into reality. Mars is the next big destination in humanity's journey through space, and the next few decades are critical in making this interplanetary dream happen. So, why Mars? Well, for one, It's the most Earth-like planet we've found so far. It has seasons, polar ice caps, and it's got a day that's just a little over 24 hours long. The gravity on Mars is about 38% of Earth's, so it's a bit weaker, but it's still enough to give us a sense of normalcy. Plus, there's evidence that Mars once had liquid water, which raises the question, did it ever support life? It's kind of like this cosmic mystery waiting for us to uncover. The big players in this mission are NASA and SpaceX. NASA's been working on getting humans to Mars through the Artemis program and their Mars plans, but SpaceX has really taken the spotlight with their Starship development. Elon Musk's goal? Getting humans to Mars in the next decade. He's been talking about establishing a human colony there. Permanent settlements where people can live, work, and even grow food on the surface. We're talking about actual cities, not just short missions. It's bold, it's ambitious, but it's a vision that's driving so much of the excitement right now. But before we can colonize Mars, we've got to figure out how to get there. And getting there is no small feat. Mars is millions of miles away, and it takes months to get there. Think about it. We're talking about a journey that could last anywhere from 6 to 9 months, depending on the alignment of Earth and Mars. That means we need spacecraft that can handle long-term missions. We also need to keep astronauts alive and healthy in deep space for extended periods. No small challenge. This is where technologies like SpaceX's Starship come in. It's designed for long-duration missions, with the capability to carry large crews and cargo. But even once we get there, we're not done. The real challenge begins when we arrive on Mars. So let's talk about landing. The surface of Mars is a hostile place. It's cold, think minus 80 degrees Fahrenheit or lower, and the atmosphere is 100 times thinner than Earth's. That means there's not a lot of protection from radiation or meteor impacts. We'll need specially designed habitats to keep us safe from those extreme conditions. These habitats will have to provide oxygen, heat, and protection from radiation. One of the biggest hurdles is figuring out how to shield astronauts from cosmic radiation during the trip to Mars, and once they're on the surface. NASA is already researching ways to build radiation-proof shelters using the materials found on Mars itself, like regolith, the dust and rocks on the planet's surface. Then there's the issue of food. How do you feed a colony on Mars? We can't just send up crates of food every year, we'll need to grow food on Mars itself. There are already experiments testing plant growth in Martian-like conditions right here on Earth, so we know it's possible. Imagine growing crops inside a greenhouse under a red sky. The idea is to create a closed-loop system where we recycle water, air, and waste. We'll need to be completely self-sufficient, especially in the early years, when supply missions won't be as frequent. Establishing a sustainable colony on Mars is going to require a lot of building. We're not talking about setting up tents, no, this will be a fully fledged colony with infrastructure for everything from power to manufacturing. That's where the idea of in situ resource utilization, or ISRU, comes in. Instead of hauling everything from Earth, we'll use the resources on Mars itself. This could mean mining the Martian soil for building materials, extracting water from underground ice, or even using the planet's atmosphere to create oxygen and fuel. And what about the social aspect? We can't forget that. Living on Mars will be tough, especially with the isolation and distance from Earth. Astronauts will spend months, possibly years, without direct contact with loved ones. They'll need to be resilient and work as a team. Psychological health will be a key focus of Mars missions. NASA's been running analog missions here on Earth, where people live in isolated conditions to simulate life on Mars. These studies are helping us understand how to keep crew members mentally healthy during long-duration missions. Let's talk about the potential benefits of all this. If we succeed in establishing a sustainable colony on Mars, it would be one of the greatest accomplishments in human history. It's not just about bragging rights, it's about survival. By learning how to live on Mars, we might discover new technologies, better ways to recycle resources, and new ways to deal with Earth's environmental challenges. Mars could become a backup for humanity if something were to happen to Earth. But beyond survival, it's about the spirit of exploration. It's the next frontier. It's where humanity shows what it's capable of when we push beyond our limits. But, of course, we're not there yet. We're still in the early stages, but the next couple of decades are going to be crucial. The technologies are advancing, and the interest in Mars exploration is at an all-time high. We've sent robots, we've orbited the planet, and now it's time to send humans. The question is no longer can we, but when do we start? Mars isn't just a distant dream anymore, it's becoming a tangible, reachable goal. And with the advancements we're seeing in the 2020s, we might just see the first humans land there sooner than we ever thought possible. Now let's dive into something that's going to play a huge role in space exploration: artificial intelligence and robotics. It might sound like something out of a sci-fi movie, but in reality, AI and robots are already here, and they're going to be critical for missions beyond Earth. They're our extra pair of hands, eyes, and brains in space, and the next few decades will see them become even more advanced and integrated into our missions. Let's start with AI. In space, we're talking about long-duration missions. These missions won't just be about humans flying up and pushing buttons. They'll be about humans working alongside AI to tackle some of the toughest challenges we'll face. AI's role is massive, from planning missions to helping astronauts make decisions in real time. One of the key benefits of AI is its ability to process huge amounts of data quickly. When you're on Mars, for example, you can't just run down to Earth to ask for help if something goes wrong. AI can act as a support system, helping astronauts with everything from medical issues to navigation. It can monitor the spacecraft systems, adjust parameters, and even suggest solutions if something's not going as planned. But AI isn't just about decision-making, it's also about learning. Imagine an AI that can adapt to new situations, learn from its environment, and assist astronauts in ways we haven't even thought of yet. In the future, AI could help build habitats, grow food, and even perform repairs on spacecraft without human intervention. Think of it like having a space companion that never gets tired, never needs a break, and is always ready to help when things go wrong. Now let's talk about robotics. If you've been following space missions, you've already seen robots in action. From NASA's robotic rovers on Mars to the robotic arms on the International Space Station, we're already using robotics to explore, repair, and assist in space. But the role of robotics is going to get way bigger. For one, robots are perfect for the dangerous tasks that humans just can't handle. In space, the conditions are harsh: radiation, extreme temperatures, the vacuum of space itself. Robots, though, they don't need to worry about that. They can go where humans can't, whether it's exploring distant planets, repairing satellites in space, or even mining resources from asteroids or the moon. These robots will be our explorers, our engineers, and our workers, getting things done when it's just too risky or complicated for humans to do themselves. But robotics isn't just about doing the dangerous stuff. We're also talking about robots that are going to help build infrastructure in space. Imagine this: a team of robots assembling a lunar base or even setting up the first habitats on Mars. They can work tirelessly, 24/7, without the need for sleep or food. And once the base is set up, they'll be there for maintenance and repairs. If a part of the habitat breaks down, a robot could swoop in to fix it, or even print new parts using 3D printing technologies. That's right, robots with 3D printers could build structures from local materials, turning resources like lunar regolith into bricks for building. It's kind of like building a home from scratch, but on the moon or Mars. And we're already seeing some of this in action. NASA's rovers on Mars, like Perseverance, are using advanced AI to navigate and make decisions on their own, sending back vital data about the Martian surface. These rovers are testing out technologies that will eventually be used on human missions. And the best part? The lessons we learn from these robots now will help us improve the design of future spacecraft, rovers, and habitats. As we move further into space, we'll also see more autonomous robots. Think of robots that are not just controlled remotely, but can think, adapt, and operate on their own. These robots will be critical for missions to the outer solar system, where it might take hours or even days for commands to reach them. Instead of relying on Earth to tell them what to do, they'll be able to perform tasks independently. It's all about making sure we can explore the far reaches of space without having to rely on constant communication with Earth. And let's not forget the potential of AI and robotics to improve the safety of astronauts. Space is dangerous, there's no getting around that. But robots and AI can help minimize the risks. AI can monitor the health of astronauts and provide real-time diagnostics, letting them know if something's wrong long before it becomes a serious issue. Robotics can help with hazardous tasks like repairing spacecraft or handling dangerous materials, all while keeping astronauts safe in their habitats or on the surface of Mars. It's all about making the dangerous work safer. Then, there's the potential for AI to help with scientific discoveries. AI can process massive amounts of data faster than humans can. In space exploration, that means we can analyze data from planets, moons, and asteroids more quickly and efficiently. AI could help identify patterns in the data that humans might miss, speeding up our understanding of the cosmos. Imagine AI algorithms combing through images from Mars, looking for signs of past life, or analyzing soil samples to identify minerals that could support human life. AI could also help astronauts with science experiments in real time, providing insights and suggestions based on the data they're collecting. It's like having an extra brain on board, one that never sleeps and can crunch numbers at lightning speed. Now let's get a little futuristic. In the long-term future, AI and robotics might not just be tools for exploration and survival, they could be integral parts of the human experience in space. Imagine having a robot companion during your mission to Mars, someone or something to help with everyday tasks, from cooking to entertainment. Maybe even personal AI assistants that help with decision-making, keeping astronauts mentally healthy, and improving productivity on long, lonely missions. At the end of the day, AI and robotics are going to be our partners in space. They'll be the unsung heroes of space exploration, working quietly behind the scenes to make everything possible. And as the technology improves, these tools will only become more sophisticated and more essential to our journey through space. Alright, let's talk about something that might sound a little wild, but it's rapidly becoming a reality: space tourism and commercial spaceflight. Now, when most people think of space, they think of astronauts, rockets, and giant government space agencies. But in the next few decades, we're going to see a massive shift. Space is no longer just for the elite astronauts and researchers. No, now regular folks, and yes, you could be one of them, will be able to experience space travel for themselves. It's a whole new era, and it's happening faster than you might think. Let's start with the companies driving this revolution. The biggest names? Well, you've probably heard of them: SpaceX, Blue Origin, and Virgin Galactic. These are the companies that are making space accessible to more than just scientists and engineers. They're working on technology that's going to take you, your family, or even your friends into orbit, or maybe even beyond, and yes, it's all becoming more and more possible every year. Let's talk about Blue Origin first. Founded by Jeff Bezos, Blue Origin is focused on suborbital spaceflight. That means you won't be heading to Mars or the Moon just yet, but you will be going high enough to experience a few minutes of weightlessness and see the Earth from space. Sounds amazing, right? The New Shepard rocket is designed to carry tourists on these brief but thrilling rides. Passengers experience a few minutes of weightlessness, float around in the cabin, and gaze out at the Earth below. The whole experience lasts only a little over 10 minutes, but for those lucky enough to go, it's an unforgettable journey. Then there's Virgin Galactic, led by Sir Richard Branson. This company has been working on suborbital space tourism as well, but their approach is a little different. Instead of a traditional rocket, Virgin Galactic uses a spaceplane that's carried into the air by a mothership. Once the spaceplane reaches a certain altitude, the rocket engines kick in and you're off. For a few minutes, you'll be able to float around, experiencing the feeling of zero gravity and seeing the curvature of the Earth. It's a more gradual yet still thrilling ride compared to what you might expect from a traditional rocket launch. But perhaps the most ambitious, and the one that's catching everyone's attention, is SpaceX. Elon Musk's company isn't just aiming for suborbital flights, they're thinking way bigger. SpaceX's goal is to not only offer space tourism, but to open up space travel for missions to the Moon, Mars, and beyond. The company's Starship, which is currently in development, is designed to carry large crews into orbit and even to the moon. Starship could eventually make interplanetary travel a reality, and that means you could be going on vacation to the moon one day. How crazy is that? A few decades ago, the idea of commercial space travel sounded like pure science fiction, but now it's becoming a real possibility. Now let's talk about why this is happening. Why are billionaires like Bezos, Branson, and Musk investing so much in commercial space travel? Well, there are a few reasons. First, there's the huge potential for profit. Space tourism is going to be big business, and these companies want to get in on the ground floor. But it's not just about the money. These billionaires have a vision for the future, one where space is a part of everyday life. They see a world where people can travel to space like they do today on airplanes. It's not going to happen overnight, but they're paving the way for the next generation of space explorers. They want to make space accessible to everyone, not just those who are already on a career path to become astronauts. The second reason? Space tourism is actually going to help advance space technology. The more we invest in commercial space travel, the more we push the boundaries of what's possible. Think about it. With each new space mission, whether it's a tourist flight or a professional mission, we learn more about space travel, build better rockets, develop new technologies, and improve the safety of space exploration. It's a cycle that helps everyone, from tourists to astronauts, researchers, and even companies looking to establish a long-term presence in space. But let's be honest, space tourism isn't cheap. If you're dreaming of a space vacation, be prepared for a hefty price tag. Right now, a seat on Blue Origin or Virgin Galactic suborbital flights can cost anywhere from $200,000 to $500,000, not exactly pocket change. But here's the thing, as technology improves and more companies get involved in the space tourism business, those prices are likely to come down. In the same way that airplane tickets used to be outrageously expensive but have become more affordable over time, space travel might eventually be within reach for more people. It might not be tomorrow, but with competition increasing and technology advancing, we could see lower-cost options in the future. There's also the environmental side of things. It's no secret that space travel isn't exactly the greenest activity. Rockets burn a lot of fuel, and the emissions from space launches can have an impact on the environment. As the space tourism industry grows, companies are going to need to find ways to make space travel more sustainable. There are already efforts underway to develop reusable rockets that can be launched multiple times, which could reduce the environmental impact. But as space tourism grows, so too will the pressure to find more eco-friendly ways of getting into space. And let's not forget about the potential for space tourism to inspire a new generation of scientists, engineers, and explorers. Imagine being a kid today, watching a space tourist launch into orbit and thinking, I want to do that someday. Just like how the Apollo missions inspired millions in the 1960s, space tourism could spark a renewed interest in space and science for today's youth. Who knows, the next big space pioneer could be someone who took a ride on Virgin Galactic's space plane or a SpaceX shuttle. In a way, space tourism is the gateway to the next era of space exploration. The more people get excited about space, the more support there will be for long-term missions, research, and infrastructure that will allow us to establish a lasting presence in space. Space tourism isn't just a fun ride, it's part of the broader vision of humanity becoming a spacefaring civilization. Alright, now let's shift our focus back to the moon, but not in the way you might think. For decades, the moon has been this distant gray rock hanging in our night sky, a symbol of human achievement from the Apollo missions. But now, in the 2020s and beyond, the moon is much more than just a symbol. It's a key part of our plans for exploring the rest of the solar system, and it's going to play a huge role in our journey to the stars. First, let's talk about why the moon is so important. It's not just about landing there again, though that's exciting enough. The moon is the perfect stepping stone for humanity's future in space. It's close enough to Earth that we can get there relatively easily, compared to other planets and moons in our solar system. But it's far enough away to provide a valuable testing ground for technologies and systems that will eventually be used on longer missions to Mars and beyond. If we can make it work on the moon, we'll have a much better shot at making it work on places like Mars or even asteroids. The moon is our proving ground for space exploration. One of the most exciting things happening right now is NASA's Artemis program. This initiative is all about returning humans to the moon, but it's about so much more than just a quick visit. Artemis is designed to establish a long-term human presence on the moon, creating a sustainable lunar base that will serve as a launch pad for further space exploration. The goal isn't just to explore the moon itself, but to use it as a stepping stone for missions to Mars and beyond. It's kind of like the first stop on an interplanetary highway. It's where we're going to learn how to live and work in space for long periods, how to use local resources, and how to develop the technologies we need to thrive on other worlds. The Artemis program is already making progress with the first unmanned mission to the moon, Artemis 1, launching in late 2022. And soon, Artemis 2 will carry astronauts around the moon, an important step toward getting humans back on the lunar surface. The first crewed landing could happen as soon as 2025, and from there, it's all about establishing a lasting presence. We're talking about lunar habitats, lunar rovers, and even the possibility of mining resources on the moon. It's a bold vision, but one that's getting closer and closer to becoming a reality. And that's not all. The moon could also be a valuable source of resources. For example, there's water on the moon, frozen in the polar regions. This water could be used for drinking, growing food, and even producing oxygen and fuel. By using the moon's resources, we could reduce the amount of supplies we need to send from Earth, making lunar exploration more sustainable. This is what's known as in situ resource utilization, ISRU, essentially using local materials to support life and operations. Water ice on the moon could also be converted into hydrogen and oxygen for rocket fuel, which could be used for missions deeper into space. It's like having a gas station on the moon for future space travelers. Imagine refueling on the moon before heading off to Mars or the outer solar system. But there's more. The moon also has a unique environment that could help us advance our understanding of space and Earth. For one, the moon has no atmosphere, which means there's no weather and no air to block our view of the cosmos. The lunar surface could provide an ideal spot for telescopes and observatories, allowing us to peer deeper into space and observe the universe in ways we can't from Earth. Lunar observatories could help us study everything from distant galaxies to the mysterious dark matter that makes up much of the universe. This could lead to breakthroughs in our understanding of how the universe works and help answer some of the biggest questions in science. And let's not forget about the moon's role in inspiring the next generation of space explorers. Just as the Apollo missions captured the imagination of people around the world, returning to the moon will do the same. It'll show the world that humanity is capable of achieving the impossible and push the boundaries of what we think is possible. The moon is an anchor for our dreams of exploring the stars, and it's something everyone can rally behind. It's a place that's within our reach, yet still holds so much mystery and potential. The next few decades will be a time of incredible exploration and discovery. It's not just about the Apollo-style landings or a few brief missions to collect samples, it's about creating a sustainable, long-term presence. We're talking about permanent bases on the lunar surface. Think about astronauts working on the moon for weeks, months, maybe even years at a time, living in lunar habitats, conducting experiments, building infrastructure, and expanding our understanding of what it takes to survive on another world. And the benefits of this are huge. The moon is right next door compared to Mars. If we can establish a permanent human presence on the moon, it'll make future missions to Mars and beyond so much easier. We'll be able to test technologies like life support systems, habitat construction, and long-duration spaceflight without having to travel all the way to Mars. The moon will give us the practice and experience we need to tackle the bigger challenges of deeper space exploration. Plus, the moon is becoming a new frontier for international cooperation. While the US has been leading the charge with Artemis, other countries like Russia, China, and the European Union are also interested in establishing their own lunar missions and bases. We could see partnerships form between space agencies around the world, working together to explore and develop the moon. Just as the International Space Station is an example of global collaboration in low Earth orbit, the moon could be the next big step in international teamwork in space. In fact, some countries are already planning their own missions to the moon, whether it's landing rovers, setting up research stations, or exploring the moon's resources. China's Chang'e program, for example, has already successfully landed rovers on the moon, and they have plans for a crewed mission. And with the rise of private companies entering the mix, we could see a whole new level of activity on the moon in the coming years. The moon is going to be a busy place, with people from all over the world working to unlock its secrets and potential. Alright, now let's head deeper into space, way beyond the moon, to our next big destination, Mars. For years, scientists, astronauts, and dreamers have looked up at the red planet and wondered, could this be humanity's next home? The idea of settling on Mars has captured our imaginations for decades, and thanks to incredible advances in technology, we're getting closer to turning this dream into a reality. So why Mars? Why is it the next logical step in our journey through space? Well, Mars is our closest neighbor in the solar system, and it has a lot of similarities to Earth. It's about half the size of Earth and has a day that's only slightly longer than ours. It's also got seasons, and its gravity is about 38% of what we experience here on Earth, so even though it's not exactly like Earth, it's the most Earth-like planet we've found so far. The potential for human survival is there, but we'll have to overcome some pretty big challenges. Let's talk about what makes Mars both exciting and challenging. For one, the atmosphere on Mars is very thin, made mostly of carbon dioxide. This means there's almost no breathable air, which makes it impossible for humans to survive on the surface without help. And then, there's the temperature. Mars is cold, really cold. The average temperature is around -80 degrees Fahrenheit, but it can drop even lower at night, not exactly cozy. But despite all this, Mars has one major thing going for it: water. In the past, scientists have found evidence that liquid water once flowed on Mars, and there's still water frozen in its polar ice caps. This is huge because water is essential for life. It can be used for drinking, growing food, and even split into oxygen for breathing and hydrogen for fuel. Mars is the best candidate we have for establishing a human presence beyond Earth, and its history suggests it may have supported life in the past. We're not just talking about a barren desert, we're talking about a planet with a potential history of life and resources. So, how are we going to get to Mars, and how are we going to live there? The first major step is transportation. Right now, sending humans to Mars is a massive challenge because of the distance and the duration. It takes about 6 to 9 months to travel to Mars with current rocket technology. Once you get there, you've got to deal with the effects of long-term space travel on the human body, including muscle atrophy, bone loss, and radiation exposure. That's why future missions are focused on developing more efficient spacecraft and protective technologies to make the journey safer and more comfortable for astronauts. One company that's making strides in this direction is SpaceX. Their Starship spacecraft is being designed with the goal of carrying humans to Mars. This rocket is huge, capable of carrying up to 100 people, and it's designed to be reusable, just like their Falcon 9 rockets. The plan is to send regular flights to Mars, eventually building a self-sustaining colony on the surface. SpaceX isn't just talking about getting there, they're actively working on the technology to make this possible, but of course it's not just about getting to Mars. Once we arrive, we'll have to figure out how to survive there. Setting up habitats will be one of the first challenges. NASA's Artemis program and other organizations are already working on habitat designs that could protect astronauts from the harsh Martian environment. These habitats will need to be airtight to protect from the thin atmosphere and radiation. And we'll need to find a way to keep astronauts warm in temperatures that can reach -195 degrees Fahrenheit at night. Some ideas involve inflatable habitats with layers of protection, while others suggest using local resources like Martian soil to build shelters, a technique called in situ resource utilization. But building habitats is only part of the picture. To live on Mars, we'll also need to grow food. The good news? Mars has the ingredients for agriculture. It has soil and it has sunlight, though it's a little weaker than on Earth. Scientists have been experimenting with growing plants in Martian soil simulants, and so far they've had some success. We'll need to get creative though. Mars has no Earth-like atmosphere to protect crops from radiation, so habitats will likely need to be covered or built underground to shield plants from the harmful radiation. But with the right technology, we could grow everything from potatoes to lettuce, essential for keeping a colony self-sufficient. And don't forget about energy. On Earth we rely on the sun for solar power, but Mars is farther from the sun, so the amount of sunlight is weaker. Solar panels will still be part of the equation, but we'll also need to explore other energy sources. Nuclear power could play a role in keeping the lights on in Martian habitats, especially during the long nights or dust storms that can block sunlight for days. Energy efficiency will be key to making sure the colony can survive. One of the biggest hurdles to colonizing Mars is radiation. On Earth, we're protected by our atmosphere and magnetic field, but on Mars, the atmosphere is too thin to shield astronauts from harmful radiation from the sun and space. Over time, this radiation could lead to serious health issues like cancer. That's why scientists are looking into radiation shielding for habitats, using materials like water, regolith, Martian soil, or even underground habitats to protect people. These solutions would help keep astronauts safe from the long-term effects of radiation exposure. Now, let's talk about the long-term vision establishing a sustainable colony on Mars. The idea is to build a self-sustaining community that can survive without constant supply runs from Earth. This would involve growing food, recycling water, and generating energy all locally. As technology advances, the hope is that the first small colony could eventually expand into a thriving settlement with dozens, maybe even hundreds of people. This isn't science fiction anymore. This is what the future could look like. The implications of all this are enormous. Not only would a Mars colony give humanity a backup in case something catastrophic happens on Earth, but it would also mark the first step toward becoming an interplanetary species. It's the next great chapter in our story. From Mars we could go further, toward asteroids, Jupiter's moons, and even beyond. But first, Mars is the test case. The lessons we learn on Mars will shape how we explore the rest of the solar system, and maybe even beyond. Alright, now that we've taken a deep dive into space tourism, the moon, Mars, and all the exciting things happening, let's zoom out and talk about the bigger picture. Where is all of this leading us? And what are the challenges and opportunities we'll face in the coming decades? One of the biggest questions is how we balance exploration with sustainability. We're talking about exploring other planets, setting up colonies and mining resources from asteroids, but all of this comes with a significant environmental and ethical responsibility. For instance, when we send missions to Mars or the Moon, we have to make sure we don't accidentally contaminate these pristine environments. It's not just about avoiding physical damage, it's also about preserving the potential for future discoveries. If we bring bacteria or microbes from Earth, we could disrupt native ecosystems, or even prevent us from finding signs of past life on other planets. It's called planetary protection, and it's something that's getting more attention as we push deeper into space. Then there's the question of sustainability. As we think about long-term space exploration, we need to consider how we make these missions self-sufficient. Right now, space missions rely heavily on Earth for resources like food, water, and fuel. But if we're going to set up permanent colonies on the Moon or Mars, or mine asteroids, we need to figure out how to source these materials locally. That's where the concept of in-situ resource utilization, or ISRU, comes in. Instead of relying on supply runs from Earth, astronauts could extract water from the Moon, use local materials to build habitats, or even produce their own oxygen. It's all about making space exploration more sustainable and less dependent on Earth. Another huge challenge is the cost. We're talking about billions, if not trillions of dollars to establish permanent colonies, build spacecraft, and set up interplanetary infrastructure. Governments like NASA and private companies like SpaceX and Blue Origin are investing heavily in space exploration, but the reality is that space travel is still very expensive. However, there's hope that as technology improves, the cost of space travel will decrease. Think about the first airplanes. Their price tags were sky high, and only the wealthy could afford a flight. Over time, as the technology matured and competition increased, flying became more affordable. It's the same principle with space travel. As more players enter the market and the technology becomes more efficient, the price of getting to space will hopefully drop. At the same time, with the cost of space exploration, the potential for commercial investment is huge. That's why you've seen billionaires like Jeff Bezos, Elon Musk, and Richard Branson diving into the space industry. They're not just doing it for fun, they see the massive opportunities in space. From space tourism to asteroid mining, there's money to be made, and that could be the driving force behind the next big breakthroughs. And let's not forget the role of international cooperation. Space exploration is expensive, and no country can do it alone. That's why partnerships like the International Space Station exist, where nations share resources, technology, and knowledge to achieve common goals. The future of space exploration will likely rely on this kind of teamwork, across countries, across industries, and even across private and public sectors. Speaking of the future, let's talk about the potential opportunities space exploration could bring. First off, there's the scientific potential. The more we explore space, the more we learn about our own planet. Take Earth observation, for example. Satellites in orbit help us monitor everything from climate change to deforestation to natural disasters. We've learned so much about our planet just by looking at it from space. And as we explore other planets and moons, we'll gain more insights into the origins of our solar system and maybe even discover signs of life beyond Earth. The possibility of discovering alien life, whether it's microbial life on Mars or signs of life in the oceans of Europa or Enceladus, is one of the most exciting scientific opportunities out there. Then there's the potential for technological advancements. Space exploration has historically driven huge leaps in technology, from GPS to satellite communications, to medical technologies like MRI machines. The challenges of living in space, like radiation exposure, closed-loop life support systems, and energy generation, require cutting-edge innovations. And these innovations often have spin-off benefits here on Earth. The technology we develop to make space travel safer and more efficient could end up improving life for everyone, from advances in energy to healthcare to material science. And let's not forget about the potential for space mining. As we've mentioned, asteroids contain precious metals like gold, platinum, and rare earth elements, which are in high demand here on Earth. The resources in space could one day help fuel industries and technologies that we can't even imagine yet. Mining asteroids isn't something that's going to happen tomorrow, but in the future, it could open up a whole new economy. We're talking about the potential to extract resources from space and bring them back to Earth, or even use them to build infrastructure in space itself. Asteroid mining could be the key to unlocking a new era of economic growth and technological progress. One of the more philosophical challenges, though, is what happens when we leave Earth behind. As we establish colonies on Mars or the Moon, or as we mine asteroids, what does it mean for our relationship with our home planet? How will we define what it means to be human when we're living and working in space? And how will we balance the need for exploration with the ethical responsibility to preserve and protect the environment here on Earth? These are big questions, and they're questions we'll have to grapple with as we move into the next era of space exploration. But let's not forget that space exploration is about more than just technology and economics. Just like how the Apollo missions inspired generations to reach for the stars, today's missions to the Moon, Mars, and beyond are inspiring a new wave of scientists, engineers, and dreamers. Space exploration has a way of reminding us that we're part of something much bigger than ourselves, that we're all connected to the universe in ways we can't fully understand yet. And as we continue to push the boundaries of what's possible, we're not just changing the way we live, we're changing the way we see the world and the universe around us.